We were started about discussing different types of solar thermal tubes. So in the first one, we were discussed a flat plate collector. I hope everyone has seen the diagram and we know that what is the main advantage of using this. And this comes under which category? Non-conventional or conventional type? And it is represented with direct and diffusion. And if people are saying it as a conventional is only restricted to direct beams. It is only restricted to only the beam light, not for other shapes or other distributed ways to reach the collector panel. Because of that reason, we people are moving towards non-conventional where we are having a much advantage, which will going to reflect on the surface. And we know that this was divided by three sections. One is a transparent glass. Next, we have an observer material, and below that, we are connecting the tubes. And we discussed how this tubes has been segregated: semi and enclosed type or free type. So we have discussed three category, right? So direct and diffused. So this comes under non-conventional. This is not conventional. See, you have a confusion again. It is non-conventional type where it can assist with both direct and diffused sunlight to hit on the surface of a collector. Fine. Okay, just tell me what material or what element you can use it as an observer. Material are preferably used. And in a huge case, if you want to use it as your daily application, which element will be used in this? You have a three option: aluminium, steel, and copper. Which one you will use? I told you what was the advantage, because it has to observe maximum radiation. Based on that, you're going to get the maximum output in terms of water outlet. So the name has been said liquid. So liquid, we preferably go for water. In sometimes to get a minimum degree Celsius during the night, we can prefer ethynyl glycol. So maximum we are preferring for copper instead of aluminium and steel in our application. I don't know, yesterday I explained and you forgot it. We are moving with next one. So yesterday we discussed about liquid kind of a flat plate collector. And today we are discussing about flat plate. Flat plate, it specifies that you are going for non-conventional kind, where you are going for air eating collector. In the place of liquid, this is replaced with air eating collector. And you can call this term as solar air heater or solar air collector. First, we'll see how exactly the picture represents. See, they are given various types of flat plate aerating collector. So you can see this, because every flat plate kind of a panels which you are using for application, definitely they will have an outer look which is made up of glass. So glass cover, and you're going to envelop the system to maintain the pressure in a system which is existing. So first you can see outer look has been given glass cover, and next we are having a observer plate, and the last material is insulation. And here they have specified which type we are using it: fin type, corrugated type, metal matrix type, and thermal trap type. So in that itself, when you are making a different connection or different application, so you are getting four different parameters. So but glass, absorbent, and insulator will be appear in this air heating collector. And one point we have to remember: we don't have any liquid kind or a fluid kind of system to circulate, or heat exchange will take place from header to the footer system. Here only air circulation, that air is acting as a fluid system. So we'll see what exactly it specifies. A solar aerating collector is similar to a liquid plate collector, means in the terms of construction. Of course, you are getting glass cover, observer, and in the place of your observing element, that is a water tubes, you are having the insulating material. Air is one of the dielectric material, right? So that's what they're considering it as a insulating. You can have different material also. So collector with a change in the configuration of the observer and the tube. So here only configuration changes, because earlier you're using water or ethanol. So in the place you are using air. The value of heat transfer coefficient between the observer plate and the air is low. See, every time we are going to calculate what is the coefficient. See, in transformer, we have a mutual inductance parameter. You're going to specify what is the K value. So that K value will going to specify that how much distance that circuits are present. Similar way, this will going to give you the coefficient value, how much heat is transferred. because that is not visible, but you have to measure the quantity. But in this case, the coefficient between this observer and the air is very, very low. And they're saying for this reason, the surfaces are sometimes rugged and longitudinal fins are provided in the airflow passage. So this is called a fin, right? So this passage will be present between your observer plate and the insulating material. Okay. So next, V-shaped or matrix or different kind you can use. So whatever the four types has been shown, insulating material shapes, whatever they say, twin type, corrugated, metal matrix or thermal tape, it will be varied depending upon the observer parameter. You can see the different shapes. It's looking like a scale, and this is a triangle. And zigzag manner you can say. These are like spacious based parallel lines and crossed manner lines. So this will going to tell you that is rough or longitudinal fins will be provided between your observer and the insulating material. Next, the principle of these collectors are where we can prefer, because if you're going for air kind of a flat plate thermal, air you are using it, where I can use, because solar liquid means we are saying we are using in boilers for daily purpose. Water, heating of a water purpose, we are using a liquid kind of a flat plate collector. But in this air, where I can use, so they are very clearly given this is for drying for agricultural and industrial process and space heating. So anything which has to be heated with the minimum heat instead of like going for welding or giving a particular heat to 1000 degrees Celsius, 2000 degrees Celsius, like furnace and all. We cannot prefer this heat. It's only applicable for drying purpose of agriculture. Like see, tomato, we are using tomato. So that can be dried and we can save it for a or preserve it for a longer duration. That can be used for medications also. So in that purposes and all, you can go for drying. Industrial, you can see paintings. Some paintings can be dried and incubation purpose. You can use this application. Okay. Here in the hair plate, some advantages are there over your liquid based on construction and corrosion and all. This concept we'll discuss here. Advantage and of course there is a major disadvantage are happening in this air heating. So we'll see one by one what are the major advantages of flat plate air heating collector over a liquid flat plate collector. And of course this will be asked for 5 marks in your exams. Write the comparison or advantages over conventional like liquid and air plate collectors. So first one we'll see it is compact, simple in construction and requires little maintenance. See this one sentence give you clear idea. Compact. Compact means just look a box where you have glass, observer, insulator. And construction wise simple, main thing you're not using any circulating tubes. You don't need to get insulators, you don't need to separate the system, or you need to intermediate with the short circuiting of the tubes and all. And heat losses. That process is not at all happening here. So that's what it looks simple and require less maintenance. Okay, if any tube damages have happened, it is necessary to be replaced with whole set. It is not like okay, mid of the tube you can take it off because it is a continuous from header to the footer. So that's what it requires a little maintenance when a tin comes under air flat plate collector. Next, the need to transfer thermal energy from the working, the need to transfer thermal energy from the working fluid to another fluid. Working fluid means from top to the bottom because we are saying header to footer. From one end to another end, it has to be transferred. But here, transferring is completely eliminated. You're not transferring any fluid form from one end to the another end because it says that air is used directly as a working fluid. Means throughout you're getting air. Air will be completely heated. It will take up the circulation so fast instead of moving from 1 to 2, 2 to 3, 3 to 4 like that. Then corrosion is completely eliminated. Corrosion. See, we are using water tubes. Water tubes, definitely some 2 years or 1 year, it will be working in a good condition. After that, definitely it will be get oxidized and corrosion will be going to happen. But here you're not using any tubes to get corrosed. So that's what they say. Corrosion is completely eliminated. Next, leakage of air from the duct is less severe. Means if you consider any leakage can happen because air means definitely it will be freely available and it can move off. But in this, it is an enclosed barrier you're using it. And in that case also, if you consider just 1 to 2% of leakages can happen in a system. Next, possibility of freezing of work fluid is also eliminated. Freezing in the sense based on a temperature. So if it is too hot, definitely the water will be circulating. Let us assume you are installing this in a cold area or polar area. What happens if the temperature goes very low? The water content can become ice parameter. So ice means, of course, it can act as a barrier for the movement of a fluid from one region to the another region. So this possibility of freezing of working fluid is also eliminated. Next, the last point, the pressure inside the collector does not become very high. So pressure means, let us link these 2 points. Let us assume we have got an obstacle of a ice which is formed in between the pipe. So what happens if started with the temperature increasing, your water has started forcing up. So you're creating a pressure in the system, so it can explode. So, but in the case, you don't have any obstacle to appear because you are having a air. Air will not melt or air will not become liquid, right? So it will be in the same form. So that's what pressure will not be varied, but it will be present for the required condition. The high standard pressure value will be maintained. Within the standard itself, your air flat plate collector will go into operate. So once again, we'll recall what are the main conditions. One is construction wise, it is compact, simple, and requires very less maintenance. And there is no need of transferring the thermal energy because your liquid is air, means your working fluid. You can't say it as a liquid, you should say it as a working fluid is air. Next, corrosion is completely eliminated. That is not going to happen because we don't have any tubes to be circulating. Then leakage of air from the duct is less severe. You can consider this as an advantage, and sometimes you can say it as a disadvantage also. But why that 1% is leaking? So you can consider that also. But as for the advantage, you can say leakage of air from the duct is less severe. Then the freezing of the fluid is completely eliminated and the pressure will not reach the high value. These are the main advantages of your air heating flat plate collector. For major disadvantages, what are the disadvantages? Of course, this is restricted to the applications of drying in industry and agriculture. Like some 10 to 15% of applications we can find it, but still it has some of the disadvantages. What are those? First, we'll see the large amount of fluid is to be handled due to low density. If you consider air, the density of air is very less as compared to the water or any other liquid. So because of that, if you want to achieve maximum output from your flat plate collector, quantity wise, you are going to have more than the liquid kind of a system or any other liquid kind of a flat plate collector. That is a one drawback. Means your mass of a quantity is increasing because of low density of a air. Next, as a result, the electrical power required to blow the air through the system can be significant if the pressure drop is not kept within the prescribed limit. Means your low density will be directly proportional to the pressure which is existing within the enclosed area. If the density goes down, means in the quantity of the system it is goes down, then the production of electrical power which you are using to blow the air will not be much sufficient to blow up or higher the pressure value. So the system can be significant if the pressure drop is not kept within the prescribed limit. See, if any system, if you take, there will be 2 points. One is lower point and the upper point. So within that, you have to operate. That is called as healthy. That's what we say plus or minus. But if it goes to below the lower limit also, then your system cannot operate. See, let us assume you have a 230 volt as a single phase supply. So 230, fine. Your home appliances are operating. Sometimes you can find that there is a fluctuation of power is happening, like 110, 120 volt. Can you see the flickering in your bulbs? Your bulbs are trying to glow, but they're not getting the sufficient input or sufficient energy to glow it off. Similar way here also, if the quantity of the air becomes less, then it will going to produce the low density and where you cannot achieve the required pressure to push out the output from the system. So that's what it is very much necessary to add more mass of air into the system. And then heat transfer between the observer plate and air is poor. Means this is like a chemical concept. you have to consider. In the earlier case, water, see for just some point of time, it will be heated up, but the point is like transferring from one tube to another tube, it is consuming more time and it will be dragged for a longer period. But in this case, there is molecules will be moving around the system, so that what happens from observer plate, that may be made up of copper or aluminum or a steel, where it absorption the high temperature created inside the air will be less or will be poor as compared with other type of a flat plate collector. And if definitely if the observation or transfer of heat, if it is goes less, then what will happen to the capacity? What will happen to the output heat you are getting from the applicant or the device? So definitely what happens? There is this less storage of thermal energy due to low heat capacity. Means one to one they are connected. If the absorption from observer plate to the air, if it goes poor, then definitely your storing capacity of a heat will definitely reduces. So here majorly they're concentrating about mass of a air and density, how it related to the pressure and how much heat will be transferred between your observer and air. And finally, what is the heat capacity you people can get it from the application. Okay, so first is large amount of fluid is to be handled due to low density. Then next one is as a result, the electrical power required to blow the air through the system can be significant if the pressure drop is not kept within a prescribed limit. Then heat transfer between the observer plate and air is poor. And finally, due to this transfer of heat becomes poor, then there is a less storage of thermal energy due to low heat capacity.